Welcome to determining reaction orders in our rate law. We're getting more practice with this problem below. The iodide ion reacts with hypochlorite ion. The active ingredient chlorine bleaches in the following way. We have OCl minus plus I minus yielding OI minus plus Cl minus. This rapid reaction gives the following rate data below. So for this data below, we want to extract from this the rate law for the reaction. So part A here. So the rate law is going to have the formula or the basic format of the rate equaling K, since this is a reaction involving the concentration of the hypochlorite ion and your iodide ion. That's going to be the basic format of our rate law. Now what we have to extract from this information here is what our orders of reaction are going to be, or what are the exponents going to be for our concentrations of OCl minus and I minus. Well, here we have to look at the concentrations. From the second concentration here at I minus, it's staying constant, so while it stays constant, we can look at how the rate for OCl minus fluctuates, or how it changes, and see how the rate corresponds to that change. So we go from 1.5 times 10 to the negative third to 3 times 10 to the negative third. That is a double of the concentration. And when the concentration doubles here from 1.5 to 3, the rate also goes from 1.36 to 2.72. That's also a double. So that is a first order reaction for OCl minus, and that is directly proportional to the rate increase, is directly proportional to the concentration increase. Now for our second one here, we have to compare the rates of when OCl minus stays the same, but I minus is changing. I minus goes from 1.5 and doubles to 3 here. You see, from 1.5 to 3. That is a double. It has increased by 1.5. So we should see also a doubling in the rate of reaction. And if we do see that, 1.36 to 2.72, since we do see that, we know that it is directly proportional, so it's also a first order reaction. So the rate law is what we have here below. We don't have to write the ones here as superscripts, but we can right now just for demonstration purposes. And the overall rate law would be 2. It was the 1 plus the 1. Now the second question is calculate the rate constant with proper units. For B, can be calculated using the following equation. So if I rearrange the rate law equation, K equals the rate divided by the concentration of OCl minus times the concentration of I minus. Now if I fill in the blanks here, K equals the rate. I can choose any rate from the information given in the problem. I'm going to use the rate of 1.36 times 10 to the negative fourth molar per second, divided by the two concentrations corresponding to this rate, which are 1.5 times 10 to the negative third molar and 1.5 times 10 to the negative third molar for your I minus concentration as well. When this is simplified, we can simplify the units first. That molar and this molar can cancel out. And when we simplify the entire expression, K equals 60.444, and the units are 1 molar seconds. If we Simplify this further with significant figures. It's 60, the point out here, molars, seconds, and that's a capital M. So that's B. That will be your rate constant. Now C asks, calculate the rate when, so for C, calculate the rate when the concentration of your hypochlorite ion is equal to 2 times 10 to the negative third molar, and your I minus ion is equal to 5.0 times 10 to the negative fourth molar. Now the rate law that we got before was equal to K times the concentration of OCl minus times the concentration of I minus, both of which were to the first order. So if we fill in our blanks here to solve for the rate equals K, which we just found to be 60, and the units were molar seconds, times the concentration of OCl minus, which is 2.0 times 10 to the negative third molar, times the concentration of I minus, which is 5.0 times 10 to the negative fourth molar. When you've gotten all this math, your excuse me, your final answer is 6.0 times 10 to the negative fifth molars per second. Your units should cancel. Molar cancels out with molar, and now I have molars per second. Those are the right units. This would be your final answer.